Today we're going to be continuing what we talked about on dividing decimals, but today we actually get to the decimal pieces, so that should be good. We want to help you guys comprehend and understand why we have the rules that we do for dividing decimals. So we're going to do a lot of the why does this rule exist before we get into actually how we do it. We're going to start by talking about using a hundredths grid to model the dividing decimals. So if I do the quotient of 30 and 57 hundredths divided by 3 using hundredths grids, that means I would have 3 whole grids and then 1 for the decimal places or 57 hundredths. Does that make sense for everybody? Now here's the key, and what they've done, they've already done it for you. They broke it down and said, I'm dividing it into 3. So to help you visualize what's happening, we're using 3 different colors. So it worked out well on the whole, because with 3 holes, that means dividing it into 3, each hole gets a whole color. Everybody good on that? Meaning all we have left is the 57 hundredths. So who remembers the rule for dividing by 3? How do I know if I can divide a number by 3? Anybody remember the rule? What is it, Sammy? What do you mean by both the numbers? We've got to do something first. Payroll?
Doesn't make them both into a whole number.
No. No. You have to add them. So 57. What's 5 plus 7? 12. Can I divide 12 by 3? Yes, so I can divide 57 by 3. That's your rule for 3s, guys. So I do that. I say, okay, I can divide it by 3, so then I have to actually do the math. So I divide the 57 by 3, it comes out to 19. So that means for each color I have 1 hole and then 19 blocks out of the hundredths. So there's 19 of the blue, there's 19 of the orange, and there's 19 of the purple, pink, salmon, whatever color you want to call that. So if I look at my quotient, how much did I have when I divided it into 3 groups? Each group, each color, has 1 and 19 hundredths. Does that make sense? I mean, I hope so, because you can literally see it. Right? So when we talk about the standard algorithm, now this is how you guys should have already known to do division. You have your 3 pieces. We've got the divisor, the number that I'm dividing it, the number of groups I'm dividing it into. We have our dividend, the number that I'm splitting up, and we have our quotient, the answer to the problem. So when I use the standard algorithm, my divisor goes on the outside. That was fun. Wrong way. My divisor goes on the outside, dividend on the inside of the house. And then I just go through place by place, and here's where your handwriting is really critical. You have to write neatly, guys, because you have to keep track of every single place value. When I go to the ones place, 3 will go into 3 one time. April, you know what? Thank you for doing that, because I think I might write your parents and tell them to look at 3 minutes into the recording to see how you act in class. Okay? So that goes one time. I then take 3 from the 3. I have a 0 left. Here's where your handwriting is so important. Wherever my decimal is in my dividend, it comes straight up into my quotient. If you're not keeping track of your places properly, you're going to mess up your answer. I then bring my next digit down, so the 5 comes down from whatever my remainder was in the first column. In this case, it was a 0, so 5 left over. 3 is going to go into the 5 one more time, so I put a 1 here. I subtract 3. That leaves me a remainder of 2. I bring down my next column, the 7. 3 goes into 27 9 times. I subtract 27. When I get to 0, I am done. That's really our goal, is to get to 0 or to see a pattern where we're seeing repeating. We'll talk about that one in a second. Does everybody understand how mathematically we came to the same answer that we had when we did our model? Does it make sense? Any questions on it? Okay, so let's go to our next page then. We're on 154. So now let's do a comparison between those 2 examples. Describe how the hundredths grid model represents different parts of the standard algorithm. So when I looked at my hundredths grid, and then I looked at my algorithm, how did those match up? I'll go back to the grid to help you guys understand it. So I'm looking at the grids. The 1 in my standard, this one here, means that each one had 1, correct? The 1 here meant that each one had 1/10, correct? The 9 here means that each number had 9 hundredths. Can you guys now see how that all came together? Okay. So the model shows by place value what the standard algorithm found. That's an H and an M. So when we look at our standard algorithm, by breaking it down by place value, you can see in the model exactly how the model showed each one of those pieces. Why does the standard algorithm show subtracting 3 from the 3 ones in the dividend? So when I looked at my standard algorithm here, why did I do this? What are you calling?
Because you're dividing 3 by 3, and then if you put 3 divided by 3 can go into itself 1 time.
There's the key. That last one he said is the big key, guys. When I'm looking at the number in the dividend that I'm dividing into groups, 3 is going to go in there 1 time. That's why I subtracted the 3. Because I've now accounted for how many times that 3 goes into the 3, yes?
Yes.
Make sense? Okay. So the reason we do it, we need to account for how many times or how many groups of 3 are in 3. Because it's also going to tell us what we have left over. What does the O5 represent in the standard algorithm? In other words, when I got to the second step here, I now see O5. Why do I have O and 5?
Because when you do the 3, you subtract each other, and then 3 plus 3 is 0, and then you drop down to 5.
Good. And why do I drop down to 5? Mabel?
Because there was nothing to divide after you subtract the third from the.
You're on the right track. Zara?
3, you have to have something as 3 or over 3 in order to make it go into 3.
But why do I have to drop down to 5? Colin?
The gap normally.
Fill the gap? The way I like to think of it, I need to look at the next place value. So I'm taking care of the ones, right? I said when I divided the ones, I can divide that into 3 groups, or 3 groups, so I need 1 in my quotient. Make sense? But now I got to figure out in the tenths place, how many do I need? So I have to take whatever's left over from the ones place and put in additionally what's in that next place. So why did we do it? We are accounting for the next place value. And the 0 had to be there because when we looked at the ones place, there was nothing left. Which is where we kind of get to the second part here. What does 27 minus 27 represent in the standard algorithm? It says use the hundredths grid model to help you explain. So we can actually physically do that. I kind of already did. So why did we do? Where did the 2 come from? Let's start there. Sorry? From the 5 minus 3. So it's saying, here's what I had left over in the tens place that I still need to account for as I look at the hundredths place. So I had 2 tenths left plus now 7 hundredths. So I need to look at that whole value, 27, to see how many of them I can get for my hundredths place, which ended up being the 9. So we did this one because I had 27 left over, and I took 27 away, getting us down to 0. In my model, what that meant was I had already taken out the tenths, so I took out all of these columns, and I still needed to take what was left over, that 27, because I had 3 colors of 9 that are left over, right? And I had to divide those by 3. So when I divided that 27 by 3, it gave me 9 for each color. Does that make sense?
Not really getting it.
Which part aren't you getting? Do you understand? We took care of the tenths when we did that.
Oh, okay, yeah. Okay.
Meaning, if I took care of the tenths, I still had these 9 blues, which would not have been colored yet, these 9 oranges, and those 9 purples that I still needed to account for. So there would have been 27 more blocks left in my model.
Oh, that makes sense.
That make more sense? Okay. So rather than keep it in separate colors by place value, they just put them all together so you can see them easier. So going back to here, I think we pretty much did it on the other piece, but the 27 minus 27 represents what was left to be divided. The big key is in how I know I'm done with my division is when I get to the last number and I have 0 left. So remember though, if I have not gotten to a remainder of 0, when I'm doing decimals, I need to keep adding trailing zeros to my number until I get to either a point where I'm repeating or until I have ended. Is everybody okay with how we broke that down? Does that make more sense to everybody? We good on that? Okay, because we're not going to touch that again. We're not going to move to the next thought, which is if I multiply both the dividend and the divisor by the same number, and that's key, the quotient remains unchanged. So if I take 2 numbers, and I multiply both those numbers by the same number, when I divide them out, it's still going to enter the same number. What do I mean by that? If I do 12 divided by 3, that is 4. Does everybody agree with that?
Yes.
Okay. What's 12 times 10?
120.
120. If I take 120 and I divide by, what's 3 times 10? 30. What am I going to get?
4.
4. What's 4 times 0? 0. What's 4 times 3? 120. 12 and a 0. Right?
Oh my God.
Okay. What if I do it by 100? 12 times 100 is
1,200.
1,200. 3 times 100 is 300. 1,200 divided by 300 is 4. Did my quotient change?
No.
No. Why? Because I multiplied both of them by the same number. In this case, we're specifically using powers of 10 because we use a base 10 counting system. Our decimal system is built on tens. For every 10, I move my decimal place once. That make sense, Jasper? Does that make sense? Okay. So you can use this information to change any divisor into a whole number to make the division of a decimal easier to solve. So we've talked about we didn't divide fractions, right? Just doesn't make sense to divide by fractions. We get that same concept as we look at decimals. We can't really divide by decimals. It doesn't make sense. So let's look at a number like this. We're now on page 155. If I have 7 5600ths divided by 3 6/10, I need to multiply both numbers by the least power of 10 that makes the divisor into a whole number, and that's our focus. I want to worry about the divisor or divisor. I never know which way to say it. It's the number that's on the outside, okay? He's the one that matters. If I have it written out in a multiplication sentence, it's the second number. That's the one that matters. So this is going to be our focus today, is making that number into a whole number. Why? Because I can't really divide by decimals. Just to show you a quick example. Remember yesterday how we did the multiplication charts? Did the multiples tables for our numbers? I'm going to just do an abbreviated one. If I were to use 3 6/10, what's 3 6/10 and 3 6/10? 7 2/10. Then it would be 10 8/10. Then it would be 14 4/10. Then it would be 3 15 18. If I have 7, do I want it to subtract 3.6? That doesn't make sense, does it? Because then I'm going to end up with a decimal, and how do I know what decimal goes into that? Makes no sense at all. But if I use a whole number, 36, watch what happens. I can still build my chart, right? Easily, 1, 2, 3, 4, 5. But now I'm just using 36. 36 and 36 is 72, 108, 144, 180. Now it makes sense, because if I have 75, it's easy to take 72 away from it, right? Does that make sense? So again, it comes down to what makes sense mathematically. Dividing by decimals doesn't make sense, so we don't do it. Especially when it's really easy to get rid of the decimal, right? I can look at it and say I have 1 decimal place, so I'm going to multiply by 1 power of 10, or 10. But if I do it here, I also have to do it here to keep it equal. Questions on what we just covered there? Guys, this is the key concept for today. If you understand this, dividing by decimals is not an issue. The only issue is going to be doing multi-digit division, but that really shouldn't be that bad. So look, now you guys can show me you actually understand it. I want you to rewrite each division problem so the divisor is a whole number. And then explain how you determined your answer. Your work can show that. So if you're showing me what you're multiplying each of them by, that will explain your answer. You only got 3 of them to do, so I'll give you guys 5 minutes. Try to do it yourself first, and then you can compare answers with those at your table. Okay, guys, you didn't have to solve it, so this one should have been easy. Again, your whole key is that divisor. That is the most important number that we are working with in division. So, how many decimal places do I have in my first divisor? 1. Meaning I need to multiply it by what to get rid of the decimal? Sammy? 10. But if I multiply this by 10, what do I need to do to the 48? Times 10. I have to do the same thing to both of them to keep it equal. That gives me 480 divided by 86. Okay? Our second one. Again, our key is our divisor. How many decimal places do I have? 2. So to move this one twice, I need to move this one twice. So I like to use arrows. If you like the arrows, any empty bucket gets a 0. If you want to look at the numbers you're actually using, I'm multiplying that by 100. So I multiply this by 100, which means I get 5,950 divided by 17. Make sense?
So, Mr. Moore, it doesn't matter how we write it, right?
No.
Because I usually just write the divisor on the outside and then go like that.
Yep.
That down there. Because just for me, visually, it makes more sense for me. But I'm used to showing the kids that way, so I just want to make sure it's okay.
Yeah, that's fine.
Okay, perfect.
The key is making sure, as long as you're moving both numbers the same amount, I don't really care where you're doing it. I'm actually going to show you a couple other ways. I just want to go through this one first.
Perfect.
So, our part C, how many decimals do I have? 2. So I'm moving it 1, 2. Empty buckets get a 0. 620 divided by 2. So I'm going to use this opportunity because I learned last class. That's why we always do the videotape the second one. So I can take lessons learned on the first one, make sure I do it. I still had a lot of kids struggling when we did it in this format. So to Miss Bryant's point, you have a couple other options. If you get really confused when it's like this, I'm going to give you two other options. Option one, write it as a fraction. 48 divided by 8 6/10. Can I have a decimal in my denominator?
No.
No, so I need to do what? Multiply it by
10.
10. But if I multiply that by 10, what do I do to the top?
I have to multiply that by 10 too.
Because for a lot of you, that makes more sense. You see that I'm actually multiplying by 1, because 10 over 10 is 1, gives me 480 divided by 86. Or, to Miss Bryant's point, she's like, I prefer seeing it as a division problem. So what if I do this? 48 divided by 8 6/10. Okay? Again, I have to move my decimal, but if I move it there, I also have to move it here. Remember, if I don't see it, it's at the end of the number. So I'm moving it, but empty buckets get a 0. That make sense? So I don't care which format you feel the best with, guys. Any of them work, as long as you understand the concept. So this one would have been 59 5/10 over 17 hundredths. So I'm multiplying both of those by 100 to give me 5,950 over 17. Or if I set it up underneath the house, 17 hundredths, I'm moving this twice, I move this twice, empty buckets get a 0. Okay? 6 2/10 over 2 hundredths means I need to multiply, oops, not equals, times 100 times 100 gives me 620 over 2. Or if I did it 6 2/10 divided by 2 hundredths, I'm moving it twice, I move it twice, empty buckets get a 0. Do all these make sense? Can you feel comfortable in at least one of those three formats? I will be honest, for long division, you have to understand this one, because you got to get to that format to do long division, guys. It's the only way I know to do it. I don't even know in the new math they teach in middle or in elementary if there's another way to do the long division, but that's still the way you do the standard algorithm. Okay, so you've seen how to divide decimals and by whole numbers. Let's think about how to divide decimals by decimals. So to set this up, we're going to kind of go through the same concept. Will 7 go into 5?
Yes. Oh, no.
No. Will it go into 56? How many times? 8. So I subtract 56 and I get 0. Will 70 go into 5?
No.
No, we'll go into 56. No, we'll go into 560. How many times? 8. Will 700 go into 5? Into 56?
No.
Into 560?
Yes. No.
No. Into 5,600?
Yes.
Yes. How many times?
Make sure you write this down.
Will 7,000 go into 5?
No.
Into 56?
No.
Into 560?
No.
Into 5,600?
Yes.
No, 7,000 is bigger than 5,600.
Oh, you guys. Oh, I was going to.
Into 56,000?
Yes.
Yes. How many times?
8.
Do we see patterns?
Yes.
What pattern do you see?
They multiply each.
Colin?
Every single time they're multiplied by 8. Well, they're divided by 8 every single time because 7 can go into 56. Well, the way I see it, right, is if I take away the zeros,
Uh-huh.
and then I basically do like the first problem, and then once I solve that, I just add all the zeros back and put the quotient where it's supposed to in the correct area, and that's how I think I would solve one like the 7,000 divided by wait, no, sorry, the other way.
Okay. I understand what you're saying, though. You're basically thinking about it in reverse in multiplication and just saying, well, if I have a 0 here and a 0 here, I really don't need to think about those when I'm doing it. because I know that's going to cancel each other out, basically. So I'm really looking how many times I'm going to 56. The only thing I would caution on that, make sure you put the number in the correct place value.
Yeah.
So as long as you're putting it in the correct place value, that's a great way to think about it. So how are the divisors and dividends in the last three problems related?
They multiply them all by 10.
They're all multiplied by by the same powers of 10.
Write it. Everyone should be writing this down.
When I say that, I mean in the first time, the dividend and divisor were both multiplied by 10. The divisor and dividend were both multiplied by 100. So I'm using the same power of 10 for both of them. Make sense? So when we calculated all four quotients, we just kind of got a little head on that. What do you notice about the quotients? What was the quotient every time?
8.
8. Did it change?
No.
No. The quotient didn't change. Okay? What happens with the quotient when you multiply the dividend and divisor by the same number? What happens to the quotient?
Wait, hold up. What happened to the quotient when you
Kellen?
multiplied it?
The quotient had more zeros in front of it.
Had more zeros in front of it, but did it really change? It didn't change. Or it stayed the same. So here's the big lesson in this, and we don't make rules based on one example, but I will guarantee you this example works for every number you use. So as long as I multiply both the dividend and divisor by the same power of 10, my quotient will not change. Okay? Everybody good on this page? Questions? Okay, let's look at our next one. Which of these expressions have the same quotient as 475 divided by 25? Pull out your highlighters real quick, because we have a side note that I really want to take note of. The definition of division is that A divided by B equals A over B. Therefore, you can already use what you already know about equivalent fractions to determine which expressions have the same quotient as 475 divided by 25. So what they're saying there, a hint they're giving you, is if I write them out as fractions and then understand what they equal, when I multiply them by the same power of 10, that will tell me that they are equal. You don't have to do that, but for some of you that may be helpful. The bottom line is focus on the divisor, the second number. You need to get it to a whole number. Whatever I do to get that to the whole number, do to the other number, seeing which ones get you to that expression. Okay? You have 4 problems. I'll give you 4 minutes. Work it out by yourself, and then you can compare with people at your table once everyone finishes to see which ones you think are the same. Okay, this should have been relatively easy. Again, I told you the key is focus on my divisor. That's our second number. In this case, I have 2 decimals, so I move it twice, meaning I need to move this one twice. If I rewrite that, it's 475 divided by 25. Check, that one works. Same thing. Here, I need to move it 3 times. 1, 2, 3, meaning I move this one 3. 1, 2, 3, empty buckets get zeros. 47,500 divided by 25. That is not the same. Here, I move it twice. I move this one twice. That gives me 47 5/10 divided by 25. That is not the same. Here, I move it 4 times. 1, 2, 3, 4. So I move 4. 1, 2, 3, 4. Gives me 475 divided by 25. That is the same. Does that make sense?
Yes.
Guys, the whole key. Look at the divisor. That runs the whole problem. I want to use the smallest number I can to be able to get it to a whole number. I don't want to start adding extra zeros to it. It just makes your math harder. Okay? But whatever I do to get my divisor to a whole number, I have to do the same thing to the dividend. So now we finally get some practice. Calculate each quotient. You only have 2 problems. So I'm going to give you guys 5 minutes to solve these 2 problems. Step 1, focus on your divisor, get it to a whole number. Do the same thing to the dividend, and then find your quotients. 2 problems, 5 minutes, go. Okay, your first step is to get rid of the decimal in your divisor. So here I have 2 spots, so I need to move this one too. So I'm actually dividing 7,440 by 12. Then I need to do the actual math. 7,440 divided by 12. 12 will not go into 7. Into 74 is going to go 6 times. Gives me 72. 2 bring down the 4. Goes into 24 twice. I still have a place to account for. And this is a very common mistake. You forget that 12 does not go into 0 at all. So I need a 0 there. Your answer is 620, not 62. You have to account for every place value. Everybody good on that one? Okay, our second one, and I had several question this. Yes, I have 2 there, but I don't care. I only worry about my divisor. I have 1 here, so I'm going to move it once here. So I'm actually going to divide 662 and 2/10 by 22. So I take 662 and 2/10 divided by 22. 22 is not going to go into 6, goes into 66 3 times. Subtract 66 gives me a 0. Bring down my 2. 22 does not go into 2, so I have to put a 0 there. And my decimal goes straight up into my answer. My next number comes down. 22 goes into 22 once. So my answer here is 30 and 1/10. Everybody good on those? Okay, one thing I really don't like about our... Yeah, don't forget about bringing that decimal up. One thing I don't like about our problems today is we don't get a lot of practice. 30 and 1/10. It's literally right here. Well, we have the video, so I'll have to check later. But I'm quite confident we'll prove you wrong, Amari. Okay, you can use fraction strips to determine equivalent decimals. We have time, but I want to get some more practice in, so I'm going to kind of do this part for you guys. I will give you a big hint. Your life is going to be way easier if you will memorize your decimal fraction equivalents for your common fractions. A lot of your common fractions are the ones they're using right here. So 1/3, if I were to bring this straight down, I can see that comes just past, well, that's not a very straight edge, but it should come right about here. Okay? So as a decimal, it's actually 3/10 repeating. 3/5. So I come and I count 1, 2, 3/5. That one is 6/10. 1/4 should be a very common one. I come down from 1/4, I come right to 25/100. 1/5, another relatively common one. I come straight down to 2/10. 4/6 gets a little more interesting. So 4/6, I would count 1, 2, 3, 4, 6 is going to come right about here. So this one is going to be 6/10 repeating.
I already did it.
That's nice. 1/6. That's our first one here. You can see it comes after 1.6. It's actually 1600ths repeating. Okay? You can also change a fraction to a decimal by using the meaning of the fraction bar. When I look at a fraction, that is literally just a division problem, guys. Now, the one thing that always messed me up as a student was remembering which one goes where. So I actually came up with a little saying to help you guys. Okay? So, when I come from a fraction and I need to write it as a division problem, here's the way I think about it. I look at this fraction as a competition. So if I'm looking at a competition, who would you consider the winner, the 3 or the 8?
3.
Okay, this may not work for you though, because I would consider the 3 the winner because he's on top, right? The winner's on top. He's the winner. He gets to go in the house. The loser gets left out in the rain. Okay? So, guys, pay attention, please. Once I have it set up, guys, please stop. Once I have it set up, now I just need to do the division. Will 8 go into 3? No, it will not. And quite honestly, it's a fraction. Should it go into the first number? No, if it does, you set it up wrong. So that's your first indication that you were wrong. Okay? So I need to add my decimal. Then I add a 0. So I start adding trailing zeros to my decimal because I need to actually figure out the decimal equivalent. How many times will 8 go into 30? 3 times. Subtract 24. Gives me a 6. I'm still not at 0, so I add another 0. How many times will 8 go into 60? 7 times. 56 gives me a 4. I'm still not at 0, so I bring another one in. 8 goes into 40. 5 times. Once I get to 0 or a repeating pattern, that's how I know that I am done. So the decimal equivalent of 3/8 is 375 thousandths. Does that make sense? Again, the big key, when I go from fraction format into decimal division, the fraction, all I need to do is the winner goes in the house, the loser's left outside. If you start doing the math and you end up with a number bigger than 1, you set it up wrong. So you just got to move those 2 numbers. Colin. We're going to talk about that right now, actually. Oh, I forgot to erase this one. That's okay. Pull out your highlighters. I still have it highlighted from last class. Okay. We have 2 more math terms. This is actually on your vocabulary sheet for this chapter, this topic. The first one is a terminating decimal. So the example we just did, 375 thousandths, is what we call a terminating decimal. In other words, I ended up with a remainder of 0. I kept going until there was nothing left to find out. That's a terminating decimal. Sometimes you're going to have a repeating decimal. I'll be honest, this is incorrectly written. When I do a repeating decimal, the number that is repeating itself, the first time I see it, I put this line over it. That is represents a repeating decimal. What this means is this decimal is nothing but 6s that goes on forever. It never ends. Okay? So here's where this is. That bar, this bar right here, is what we call bar notation. So add that to your note there. Bar notation, that's this bar that shows that the number is repeating itself forever. Okay? Unfortunately, we're down to 10 minutes, so I'm going to do a couple of these really quick. I want you guys to follow along and ask questions if you have them. But the first, actually, you know what? The first thing I want you to do, I want everybody just to do this. For every problem, all 6 of these, put the numbers in the house and outside the house properly. This should take you all of 30 seconds, but I will give you 1 minute. Go. Okay, if you remember my saying, the winner goes in the house, the loser's outside. Okay, I'm not going to do all these because quite frankly we don't have time, but I'm going to do a couple just to make sure everybody understands the process. So on the inside I'm going to add a decimal and a 0 because 8 won't go into 1. My decimal comes straight up. 8 goes into 10 once. Subtract 8 leaves me a 2. Still not at 0, so I add another trailing 0 to bring down. 8 goes into 20 twice. Subtract 16 gives me a 4. I'm still not at 0, so I add another trailing 0 and bring it down. 8 goes into 40 5 times. Now I have a terminating decimal. So 1/8 as a decimal is 125 thousandths. Make sense? I'm going to skip to part C. 3 will not go into 2, so I bring my decimal straight up, bring a trailing 0. 3 goes into 26 times, gives me 18. Subtract that away, and I get 2. Anybody see a pattern? Should. So will that ever end?
No.
It will never end. So my answer is 6/10 repeating. I put the bar notation right there where I see the repeating begin.
Oh, we did, okay.
Okay.
We learned how to do it, but we never learned.
Now we do one more. We do the 6 divided by 1. We do E. Will 6 go into 1? It will not. My decimal comes straight up. Subtract 6 gives me a 4. So you have a 4. I'm not at 0. So I need to bring another trailing 0. 40 is going to go 6 times. Subtract 36 gives me a 4. See a pattern?
No.
Will that ever change?
No.
No. Did the 1 repeat?
No.
No. So a bar does not go over the 1. It only goes over the 6. Does that make sense? Okay. So there were 3 examples for switching those. And unfortunately, we're about out of time. So I want to go to your homework so we can have time to cover this. Please go to page 163. Guys, please stop the noises. We're on recording here. Just open your books to 163. It doesn't take a lot of noise. A few things. Our first one, our journal entry. Describe what is meant by the operation of division using the terms dividend, divisor, and quotient. So there are several ways you can do it. I would personally do it with a diagram. So you can show me, like a long division, show me where each of those things are. Our practice, the local superstore had a surplus of 10,000 pencil packs and decided to donate them to area schools. There are 27 schools and the store wants to donate the same amount, same number, to each school. How many pencil packs will each school receive? We need an interpretation in your remainder for that one. Write a different division expression that has the same quotient as the division expression given. Huge hint here. Focus on the divisor. Okay? So I'm looking at this one to figure out what I want to do to make my equivalent expression for every one of those. Make sense? Do I actually have to solve any of those?
No.
No, it does not say calculate. So all you're doing is rewriting it using how you would write it. Okay? Number 3, estimate each quotient. Then calculate the quotient using long division. Round to the nearest hundredth. That's actually really key. So we got 2 parts. Estimate the quotient, calculate the quotient. Having just checked this last assignment where we had the same thing, had an awful lot of kids skip one or the other. Had a lot that did the estimations and never calculated. I had several who calculated and never did the estimate. You have to do both. Does that make sense? Is everybody clear what to do? I will give you a big hint. When you're estimating, just make the numbers easy to do. They don't have to be perfect roundings. Estimation is just getting the numbers close. So you have the ability to round up or down for each of the numbers. Just don't do it. Do it to the closest ones you can to get a good estimate. So you have 2 on this page to do, and you have 6 on this page to do. Okay? Remember, your key concept, you've got to get the divisor into a whole number. Then you can do the division. Any questions on your homework?
Wait.
Question? No? Okay. Good luck. Good luck.